All right, 9.2, scatter plots. So we're going to continue looking at scatter plots, but we're going to focus on our line of best fit. And I kind of alluded to it yesterday when we had the arrow, which showed the trend, whether it was positive, negative, or nonlinear. So we'll go into a little bit more detail today. So the objective is to determine the correlation of a scatter plot and draw a line of best fit, then write an equation. So we're going to do some extra work today. Let's go a little bit further. All right, so I want you to write this definition down. A line that blank represents the data on the scatter plot. So if we wanted to represent, what word do you think would fit in that blank? Anybody? What word do you think would work there? Hello? Best. Perfect. That is the word we want to fill in that definition. Go ahead and write that definition down. So it is used to do what with events? If we're looking at data and we are plotting information, we're looking to do what? What do you think? Give me a guess, which is kind of a hint. If we're looking at data and we're charting it and we're using a line of best fit, it's going to tell us what about our data? Go ahead. It's going to determine, so it's going to help us make a prediction about the future in that set of data. So we're going to predict or estimate events. All right, so go ahead and make sure you have this graph copied down. But just by looking at that, what kind of, if I were to draw a line of best fit, what kind of correlation would that be? Right, it would be a negative linear correlation. And the way I know is if I were to draw a line that best fits there, that line of best fit would tell me that it's negative, it's going downhill. So if I were to create an equation, it would be ny equals mx plus b, or slope-intercept form. Okay, go ahead and copy this down. All right, so in order to do that slope-intercept form, we need to find two places where it intersects exactly at our points. So here it's intersecting. So we know that the y-intercept is going to be 4. And where else do you see it intersecting? Here maybe? Oh, looks like this one might be right. So we're going to look for our slope-intercept. So we went down how many? 3. And right how many? So my 3 is going to be positive or negative? So my slope is going to be negative 3 over 4. And that's how we find the equation using our line of best fit. So one clue, that I might want to give you is when you do create your line of best fit, make sure you're crossing this y at an intersection. So you get a good whole number for that here. This is okay to become a fraction. We need a rise and a run. Okay? Any questions? No questions? Take out a sheet of graph paper. If you don't have it, I will pass it out. Raise your hand if you need graph paper. All right. So the table shows the number of absences in the final grade for each student and a sample. Okay? So if you look at their number of absences, for 0 absences, their final grade was 95%. Okay? So you're going to make a scatter plot. Okay? So you're going to draw a graph with an x and a y. The x is going to be your number of absences, and the y is going to be your final grade. go ahead and use your graph paper and create this graph. All right, so there we have our values, right? It's down by 10, but if you notice, every line is a digit. So for number of absences, 0, 1, 2, 3, they just skipped to make it easier on them. And same thing with your final grade percentage. Instead of writing 10, 20, they skipped a line. Okay, but it's the same values that we've just discussed. So we're going to plot. There's 0.95. For 3, we had 88, so that's just under. For 2, we had 90. For 5 days, we're at 83. 7 days, we're at 79. You should have already plotted these. For 9 days, we're at 70. 4 days, we went back to 85. 1 day, we're at 94. And 10 days, we were down at 65. So do you guys see a trend? You don't see a trend. What does the trend tell you? So let's use a sentence here. Let's make that correlation. What's our correlation? We have 4 choices. What is it? Negative linear. Okay, so our correlation is a negative linear, right? What's the situation? Let's describe it in a sentence, like we did for your homework last night. As what increases, what decreases? Christian? Perfect. So as your absences increase, or the number of absences increase, the final grade decreases. Can you turn that alarm off so it doesn't go off again in this class? Because the next time I'll take your phone, your watch, every day this week. Do we see the correlation there? Okay. So now we're going to draw a line of best fit. Now remember, where does it cross y? When x is 0, what is your y? So looking up here at our graph, we're looking at the graph. These are our what? Absences what? X or y? Oh, X. Okay. Here's my X. Oops. X. Ugh. So what is my final grade going to be? X or y? No, y. Y. Okay. So when x is 0, what is y? 95. So that's going to be your what? What do we call that? When it crosses that y-axis, what do we call that? That's your y-intercept, right? Right? So we want to start at where x is 0. And then draw a line, getting as much as or as close to we can. Does that make any sense? So now we're going to write an equation in slope-intercept form. So that means it's going to be y equals something x plus b. So what is my y? We just talked about the y-intercept. Y is going to be what? 95, right? So let's look and see if we can find, okay, another point that intersects pretty much closely. And you could use the points above here. You use these points to figure that out. It looks like at 2 we have 90, right? That might be a good one. So y equals mx plus b, so we know that y is going to equal something x plus 95, right? We got that squared away. My presentation chooses this one here. So at 5, my x is 83, so we're going to go. So let's look at it again. Sorry, I had to go to the next slide. So count down, right? It's going to be a negative. And then right. So from 95 to 83, how far did we go down? There's two ways to do this. Okay? Look at the ordered pairs up there. Okay? We have this ordered pair, 0 and 95. And then we have 5 and 83. Okay? Does that make sense? Those are ordered pairs, right? Those are our points that we graphed on our plot. Are they ordered pairs? Is one an X and one a Y? Yes? Yes? Yes. So I can use this formula, can I not? And those ordered pairs to find my slope, could I? Absolutely. So I'm going to label x1, y1, x2, y2. I already wrote my equation, so I'm going to substitute my values. Go ahead and substitute your values and solve and tell me what your slope is. Oh, wait. I'm sorry again, what's a slope? It's what?
12
Are you sure it's 12 over 5? Do you guys agree?
Yeah.
We have some disagreement, right? Why do we have disagreement? Grant? It's a negative 12. Right? Because 83 minus 95 is going to give you a negative 12. 95 is a bigger number, and it's negative. So here's a common error. Had you used column method, you would have known that it's negative. Right? If you use column method when you're adding or subtracting negative numbers, you will not have the problem that and make those simple mistakes. Column method is going to save your life in high school. Please remember it. I recommend that you use it. So now I can add into my equation, my slope is negative 12 over 5. Correct? So we have all these notes written down. Yes? So what is the equation for the slope of the table that shows absences in the final grade? Y equals negative 12 over 5x plus 95. Okay? So you can create an equation for any graph using a line of best fit. Questions so far? Last one. Predict the final grade if a student says they're absent for 6 days. How are you going to do that? What does that X stand for? Number of absences, right? So if a student is absent 6 days, what can you put in place of that X? He's absent 6 days. In place of the X, what would you write? 6. You'd rewrite your equation with 6 instead of X. Right? So put 6 over 1, do your multiplication, add 95, and give me an answer. Go. Okay, so if I wrote this over 1, two ways to do it. I have negative 12 divided by 5. That's going to give me a negative 2.4. If I multiply that times 6, either way, I'm going to get 14.4. If I turn 6 into a fraction, and I multiply across and then divide, 72 divided by 6, I'm still going to get 14.4. So it doesn't matter the direction you take to get there, your answer for negative 12 over 5 times 6 should be a negative 14.4. Am I right? So then you have a 95 at the tail end there. So you're going to take that 95 and subtract 14.4, and what does that give you? So your answer, rounding up, is going to be approximately, that's where the equal line becomes a squiggly, 81, because we're rounding up. Right? So I can predict that a student who is absent 6 days will earn an 81%. Okay? Not great, but it's passing still. Any questions on how we just did this? No questions? No? Everybody have this written down, or do you need more time? Everybody has it written down? Nobody needs more time. Great. Make sure you guys are on your homework graph paper, because we're going to do the first one together. So first one we're doing 4 through 9, right? So we're going to look at number 4. Okay, so it says, blueberries. The table shows the weights Y of X pints of blueberries. So we're going to have to create a graph. Okay, so if I'm looking at my X, it goes from 0 to 5. And if I'm looking at my Y's, it goes from 0 to, looks like 3.75. So I'm going to go ahead and set up a graph. Here's number 4. Why am I using a pen? Breaking my own rule. And I'm going to create a graph. I'm going to go 10 up and 10 across. Okay, so here's my 0. This is my X. This is my Y. So it starts at 0, 0, right? So let's label it. I'm going to go 1, 2, 3, 4. Actually, let's spread this out on the X down below. Let's spread it out, because we're only going to 5, right? So I'm going to go 1. I'm going to skip 1, do 1. Give myself some space. Skip 1, do 2. 3, 4, 5. And I'm going to do the same thing on the left. Skip 1, do 1, skip 1, do 2, skip 1, do 3, skip 1, do 4, skip 1, 5. Because I have some decimals here that are going to make my graph a little bit more, you're going to need some more space to put that, okay? So starting 0, 0, there's my first point. So what do I know right off the bat? Where's my line going to cross my y-axis? At what number? At 0. So I already know part of my equation, okay? That's my first bit of information. At 1, it's going to be what? What's my y? 0.8. So not quite 1. I'd say around here. Quick guesstimate, right? For 2, where am I going to be? 1.5, so 1 and a half, about here. I'll move it up. For 3, where am I going to be? 2.2, so just a little bit above 2, around here. Yes? For 4, where am I going to be? Exactly at 3. So I like this number, and I also like that. I'm going to circle those two because I might need those later. At 5, where am I? 3.75, so not quite 3.5, a little bit more around there, not quite 4. Okay. We have our graph. You guys have a graph too, right? For B, it says draw the line that you think best approximates the point. So we're talking about a line of best fit. Okay, so I'm going to take my straight edge and I'm going to come out here and I'm going to say, you know, I liked that it went through 3 exactly right, so I'm going to go like this. This is my line of best fit. and then write an equation. So we're going to say y is equal to something x plus b. But we figured out that b is what? What do we say our b is going to be what? 0, right? So I'm not going to use that. I'm going to drop that once I'm done. And then I also said that I liked this number here because it was exactly at 3.0 when it was at 4. So I'm going to use this point here and this point here, right? So I'm going to do, right, m is equal to y2 minus y1 over x2 minus x1. Then I'm going to go ahead and I'm going to substitute my information. Oh, first let's write our ordered pairs. So we're going to say 0, 0 is my first one, right? And then my second one is going to be 4, 3. X1, y1, x2, y2. So let's go ahead and substitute. What is my y2 value? So I'm going to put a 3 in here. What is my y1 value? What's my y1 value? 0. Okay, what's my x2 value? And what's my x1 value? Again, 0. What is 3 minus 0? And what is 4 minus 0? I'm going to have you sit up there right now. All right, so what is my slope then? Good, so I can just substitute that here, right? Okay. So here's my equation. My equation is y equals 3x. I don't need to put the plus 0. So here's my equation, right? This would be C. Here's one at A and B. D says to use the equation to predict the weight of 10 pints of blueberries. So X is going to be what? 10. So I'm going to write my equation. Y equals 3/4 times 10 over 1. And solve that problem. What is 3 times 10?
30.
What is 4 times 1?
4.
What is 30 divided by 4?
7.5.
So it's going to be approximately what? We're rounding. 8. Approximately 8 pounds. Okay, so the weight of 10 pints of blueberries is going to be approximately 8 pounds. So this is going to be your answer for D. Last question says blueberries cost $2.25 per pound. How much do 10 pints of blueberries cost? So we're going to take, it doesn't matter if 10 pints are 8 pounds, right? We're going to take the price per pound, which is $2.25. So here's E. And multiply it by 8. And that will be my answer. Sorry, you guys can't see that. Okay, so 225 times 8 is what? $2.25. So 2.25 times 8 is going to give you a total of So 8 times 5 is what? What's 8 times 5? 40. Carry my 4. What's 8 times 2? What is it? 16 plus 4 makes it? Carry my 2. What's 8 times 2? Plus 2 is, what is it? 18. How many decimal places? So from here, I count 2 decimal places. What is the cost of 8 pounds at $2.25? $18. Okay, good luck.